Okay, in the previous module, we just saw how to apply a current divider rule in a network consisting of only resistors and a current source. In this particular case, we see there is a current source IT, and that current is being fed to a network consisting of resistor R and a capacitor C. This IT is divided into two parts, that is IR, which flows through resistance, and IC, which flows through capacitance. Now, in this circuit as well, we can apply the current division rule. If suppose I want to know the value of current flowing through the resistance R, so what I will do is I can use the current division formula, and with that I can calculate the value of the current flowing through a particular component. So for example, I want to know the IR. I will take the reactance or impedance of a opposite component first and divide it with the sum of the reactance or impedance of that component plus the resistance of the resistor through which I want to calculate the current. So once again, I can write IR to be equal to 1 over j omega c divided by 1 over j omega c plus r, and it would be, this factor will be multiplied by the total current IT. So if you solve this numerator and denominator, if you simplify this, you come across this equation, that is the current flowing through the resistor R would be 1 over, in the numerator you have 1 and in the denominator you have 1 plus j omega CR, and multiplied it with the total current IT. So that's how you can calculate actually the current through the resistor R. If suppose I challenge you to calculate the value of IC, so IC would be calculated in this way. You write IC, that will be equal to, take the opposite resistance first in the numerator R and divide it in the denominator. You have sum of the resistance plus the reactance or impedance of this capacitor, which is 1 over j omega c, and you multiplied this value with the total current IT, so this IT will be there. So you can simplify the numerator and denominator and you will get the expression for the value of capacitor. Imagine you have an inductor instead of a capacitor. So the exercise for you is to write a current flowing through the resistor and then a current flowing through the inductor. And the third exercise for you would be, let's say you have a similar network of R, C, and you also have an inductor with the circuit with the value L, and the current flowing through the inductor will be IL. Let's say IL, and you are asked to calculate with the current division rules the value of IR, the equation for IC and equation for IL. So simply apply this formula and you can know the value of the branch currents consisting of all passive components. So hope you like this video. If you like this video, share with others and subscribe to the channel.